Hello, I just wanted to give you a quick update and maybe provide some help on this sandwich stoichiometry or intro to stoichiometry lab. I will tell you, even though I've been sick, I have been able to monitor what you've been doing on Classroom because I can see your assignments. And I will say that some people I've noticed have not done anything or very little. I don't know if that's because you don't understand or whether you just have not been doing anything. But this simulation is due at the beginning of class on Monday, so make sure that you are working diligently. One thing I will say, I just wanted to give you a brief little introduction on this in case you were confused. And so I had some questions via email, so I wanted to address them. What I'll do is I'll just go through each part one, part two, and then I'll scroll down to part four, and then I'll do the game, give an example of the game. And so when I come to the simulation, here I am. And so it says 3 and 7 for bread and cheese. And so all I need to do is say 3 and 7. And notice that the reaction up here requires 2 slices of bread, just like my tab here, my Google Doc. I've got 2 bread, and then I need 1 cheese, and that's going to form 1 sandwich. I just wrote that as a formula. Well, here is me doing that again, except now I've just entered the data, and so it tells me that I have 1 product that forms. And so on my sandwich I'd say 1, and for my leftovers I would say 1 slice of bread and 6 cheese. And so I'd say 1 BR, comma, 6 CH. And the reason that is because you run out of bread. Like, for instance, if I had another slice of bread, I could make another sandwich, but I have run out of bread. That's because the bread limits how much product can actually be made. And so when thinking about this, I can think, okay, well, I have enough bread based on my reaction up here to make 1 sandwich. I have enough cheese up here to make 7 sandwiches. So how many sandwiches can I actually make? Well, I can obviously only make 1, then I'll have the rest of those be left over. Okay, so that's an example of the first one. Now I'm going to delete this guy down here. And then when I scroll down here, I will do the same using the meat and cheese. So now we'll go 4, 8, and 5. So I'll go 4, 8, and 5. So notice the chemical reaction here is 2 slices of bread, 1 meat, and 1 piece of cheese makes a sandwich. And so now, by thinking about this, I can say, okay, well, I have 4 slices of bread. Okay, that is enough bread to make 2 sandwiches. So, based on the reaction, I have 8 slices of meat, therefore I have enough meat to make 8 sandwiches. I have 5 slices of cheese, that's enough cheese to make 5 different sandwiches. Well, how many sandwiches can you actually make? Well, you can make 2 sandwiches. And so therefore, that's why you only have 2. So therefore, you have 2 sandwiches. You have no bread because you've used up all your bread. And then you have 6 meats because 2 of those are required in each sandwich. You're going to have used 2 of them, which is going to leave 6 left over. And so 6 meat are left over. And then you have 3 cheese because you've, again, made 2 sandwiches, which is going to require 2 slices of cheese. So therefore, you're going to have 3 cheese left over, just like that. Okay? So I think you get the idea of part 2 and part 3. So now I'm going to scroll down to part 4 here. And so now I went in and answered these questions up here. Let's consider a real reaction in which water is produced from hydrogen and oxygen gas. How many moles of hydrogen are needed for this reaction to occur? Well, it gives me the balanced chemical reaction here. Let me reset this. Right up here, when I say how many moles, that we're looking at the coefficient in front. And so therefore I need 2 moles of hydrogen gas. So 2 moles of hydrogen gas are reacting with 1 mole of oxygen gas to form 2 moles of water. And so when I do this now, I'm going to plug in the numbers 3 and 7. So I'm going to say 3 here, 7 here, and then voila. Well, if I look at this, if I have 2 moles of hydrogen, that's going to create 2 moles of water. And so I've got 3 hydrogens, 3 moles of hydrogen. That's enough to make 2 moles of water. And then that would leave 1 leftover hydrogen. Well, I have enough oxygen, according to this, to make 14 total waters. But obviously I'm not going to be able to make 14 because I don't have enough hydrogens. And so therefore, here's what we're going to have to do with in terms of leftovers. So I know it's either going to be, I'm going to make 2 or I'm going to make 14. Well, obviously I'm only going to make 2 waters. And so therefore I'm going to have 2 water products. So if I can make 2 waters from that, then I know I'm going to have 1 leftover hydrogen, 1 leftover H2, and then we will have also, because I'm only making 2 of those, look at my ratio here. Well, if I'm making 2 waters, that's only going to require 1 O2. And so therefore, I'm going to have 6 O2s that's left over. And so I'd say 6 O2. So that's the oxygen and hydrogen. So similar with the ammonia and the combustion combustion of methane. Now I will say down here there are a couple that you can't put in the simulation, so it's going to require you to think a little bit. Down here in the game, let me get rid of this. Down here on the game, let me just give you an example of how you should do this. So I'll start with level 1. And so the first thing I want to do is I want to interpret what this reaction is telling me up here. So I'm going to say, okay, I know I have 1 mole of carbon reacting with 1 mole of carbon dioxide, and it's forming 2 moles of carbon monoxide. So the first thing I want to do is look down here at the numbers, and I want to say, okay, how many moles of product were formed? Well, I see 8. And so if I see that 8 products are formed, notice my ratio here. If I have 2 that form, I would have needed 1. If I had 4 that formed, I would have needed 2 of the carbon dioxides. If I had 4 carbon monoxides that were formed, I would have needed 2 carbon dioxides to produce that. Well, if I had 8 carbon monoxides that formed, I would need half of that, which would be 4. And so I'm going to say 4 on those, but also notice the ratio from carbon monoxide to carbon. It's also half, and so I need 4 of those as well. And so just to make those 8 products, I need 4 of each of them. Well, now I look over here on the leftovers. I don't have any leftover carbon dioxide, so that is set in stone. I have 2 carbons that are left over, and so therefore I'm just going to add 2 more over here. Check, and there it is. And so when I type that into the Google Doc, what I'm going to do, you only have to do this for the first 4. Okay, my reactant 1 was carbon, and I knew that there were 6 of them. Reactant 2 was carbon dioxide, and I needed 4 of them. Product 1 is carbon monoxide, and I produced 8 of them. I didn't have a product 2, and the leftovers I had 2 carbons, and that was it. So I'd say 2 carbons. And that's it. So then, now, when you complete the game, you need to first do your first 4 on this table, spelling it out. Then you're just going to do the rest of them as a game on your own. The score must be 4.5 or 5 on every single level, and you must put a picture of that at the game. Now, down below, I'm not going to have you answer the post lab. We'll talk about that in class on Monday. But all the rest of this should be completed at the beginning of class on Monday. Okay, hopefully that answered some questions.